Okay, let's start to do the revision paper. First of all, I would like to remind everyone on the setting of the machine. If you are running a new computer, you will not have the default machine installed correctly. So we'll go to machine, go to mute. Well, if you are using your own computer, the one that you used to use, you have this. But in case if it is a new computer, your configuration file is not installed, so you have to do manage list, and after that you will use a browse, this icon here, browse, and you browse to, first of all, navigate to CNC machines. Underneath that you will see a folder, single poly. So once you highlight that, okay, and you will see the one something like this. So what you need to do is highlight this and add it to right. Okay, so when you are done, retake. Okay, so for my case, I don't have to. Okay, so anyway, I have the machine with me. So this is the massage machine, vertical milling machine. So now the next thing is I want to merge the file. File, merge, and I will navigate to my folder and all files. So you will have to you can download this file from Breadboard. So this STP file, open it. Okay, so this is the workpiece. Okay, so the question first of all asks you, what is the proper orientation for this part to be machined? So if you look at it from this isometric view, is this side is like this, then the other side is like this. So the point here is that you see this is a big curve. Although these are flat surfaces, but at the center, this is the curvature part. So making it difficult for us to clamp on this surface here. So possibly a better choice is to machine from this end. Okay, this at least we got some flat surfaces. These two flat wall can be mounted on the vise, on the fixed jaw and the sliding jaw on the vise. So this will be a better approach as compared to this. So when there is a case, we will have to rearrange the workpiece so that it is at the correct orientation. So now back to the top, this is what we have worked out with originally. And in order to get to this shape, I would like to go to my right. My right is like that. Now I want to rotate the workpiece. Remember, rotation is always perpendicular to the screen. So this is the workpiece. I want to rotate it. I want to rotate it so that this is facing up. We are going to do this machining this end. So I go to say transform, rotate, select the workpiece and selection. And remember, we always want to move, not copy. And I want to rotate it 90 degrees. So when you enter, okay, so you see that now this case is not right. Minus 90 degrees. Okay, this is okay, all right, correct. What happened is that now I'm having this facing up. Okay, so I want to machine this part here first. So retake. So even when there is a case, you can go to front. And go to the front now. So this is the front view. Our G54 should be on top, not along this line. So I still need to translate the workpiece. Again, I will have to bring this copy. Workpiece go down by minus 10 mm. You can take a look at your drawing and look at the drawing. The drawing here shows that we have we will go down by 10 mm. So I call out the drawing. So this is the part 25 minus 15. So I need to bring this down by 10 mm. Okay, so let's go back to Mastercam. Okay, so I will bring down by, so now my G54 is on top of the raw piece. So with that intake, now I go to the top. This is my top. I'm going to mill this first. After I finish milling all this, these are the flat surfaces. When I put onto the, when I do the second side machining, this will be going into the rise and supporting the rest of the work piece. So isometric wheel is like that, and front wheel is like that, top wheel is like that. Okay, so let's continue. Okay, go to tool settings, program number. We will have to look at the question paper. So we are asked to use this number 2001. Okay, for side 1 2001, side 2 is 2002. So 2001. Use two-step pack and coolant, and we have to change this value here. Edit. So what value do we want to change to? So again, we go to the question paper. It got tell us these values here. So we'll then enter these values into here: 60, 0.05, and 400 mm for the carbide tool. With that, green tick. And so now we are done with this. Then stock setup. So we have to input the raw materials here. So I will go to the paper. The raw material itself is 90 mm, 130 mm on the x-axis, 90 mm on the y-axis, 34 mm on the z-axis. So I will have 130 here, 90 here, 34 here. So these values is the raw material size, the size of the raw material. And also, if you look at this, it got tell you that the first operation is a facing operation. The facing amount is 0.5. So in order to machine it up to G54, I will have to bring this up by 0.5. So this raw material will be above the work piece by 0.5 mm. Then when we want to machine, I will just remove this 0.5 mm to get to G54. Okay, so with that, we are done. Green tick. Okay, we go to toolpath and we click on this icon to display the raw material. So now you see that this is raw material. The raw piece is nicely located inside. And if you look at from the front, again, this is the 0.5 mm that we have to remove in the facing operation. So, okay, back to isometric. And now, first operation, facing. So this, we don't have to do anything, just green tick will do. And tool. So we have to define our tool. So right click, create tool. First is the face mill. This is the first operation is face mill. So we can, okay, next we can check the paper. We can check the paper, the face mill, the face mill is here, 63 mm diameter, 7 flutes with a taper angle of 0 degrees. So we come to here, 63 in diameter, but the angle is 0 degree. So with that, the image come out. Next, to number 1, that is correct, but number of fruits that we have over here is 7 fruits, and material is carbide, correct. So we will then calculate the spindle speed and the feed rate, and of course, don't forget that turn coolant on for all tools. So with that, our first definition is complete. Finish. Followed by cut parameter. Again, if you look at the paper, it says that the first operation is phasing, zigzag, high-speed loop between passes. So zigzag, high-speed loop, and we are not going to have any other phasing operations, so we will cut to 0. Depth of cut, we can uncheck because it is only 0.5 mm. One cut we can finish all. Linking parameter, 50 on top, uncheck retract. Flip plane is 5 mm above. Top of the stock is 0.5. We will cut to 0. G54, absolute. So we are removing that 0.5 mm. So with that, green tick. So this is the phasing operation. Okay. So we will now go to the second operation. The second is a rough milling of the external contour. So we will have to cut this external contour. So we'll say contour, and we'll use loop, and we'll now select one of these edges. So this is correct. Green tick, and green tick once more. The tool that we want to use, right click, create tool. So we will now see the paper. What is the we are doing the roughing now. Okay, we are doing roughing. So we want to use a bigger tool. So possibly this is roughing. So we want to use a 25 mm mill. The bigger it is, the more material you can remove in a rather short time, more efficiently. Okay, so here we say mill. Next, 25 mm mill. So with that, next again. This is tool number 2, correct? Number of fruits, however, is 2. And material is carbide, that's correct. So calculate the speed and feed. Again, coolant on. So with that, finish. So this is tool number 2 that we are using. Cut parameters. The paper got tell us, okay, we are using computer for compensation. Where? Here. Compensation by computer. Okay. Compensation on the left. And for every closed loop, we'll be using 1 mm. So this will apply for all contour milling and pocket milling processes. So we see that computer, correct? But we want to have 0.2 mm for the finishing operation. Then depth of cut. Again, here you see that rough cut is 15% of the tool diameter. So with that, we say activate. Then we'll input a formula. This one is say 15%, 0.15, or I type a 0 as well to make it clearer to you. 0.15 times 25 mm diameter. So this is the depth as indicated in the question paper. So enter. So 3.75 is the value, and I want to keep 2 down. Okay, followed by lead in, lead out. Again, the paper also could tell us, okay, the for the operations we'll be using this line perpendicular, radius 100%, sweep angle 90 degrees for all closed loop. So since we are now doing the closed loop, so line is perpendicular, 100%, 100%, copy from left to right, and also we would like to have overlap. This is a closed loop operation. So we are applying all this. Okay, so followed by linking parameter. Okay, one more thing. Okay, look at the drawing. The drawing is here. Okay, this is what we are doing now. So we want to cut this. This is 87. This whole length is 120. Okay, 87, 120 minus 87. Okay, let me get the calculator. (120) minus 87. So I have a 33 mm. So meaning that 15 we over here, 33 mm left behind. So I will have about 33 divided by 2, about 16 mm over here, 16 mm over here. Okay, so let's continue first. Okay, so let's start with this. Continue with this clearance, uncheck retract. 15 is 5. So we have to find out absolute is 0. Go down by how much? So again, we look at the drawing. We go down by this amount. This is 10 mm. So go down by minus 10. Okay, so when we say green tick, alright, so we look at the top view now. And we can do a simulation. So what happened is like this. Actually, just now the calculation I was trying to show is this. When we are doing like this, actually we are, some of this material is not being cut. Okay, so you see that the material over here is not cut. This corner as well. So we come to here. So you see some of this material is not cut. Okay, so we say that in this case we need to modify this. I have to engage multi-pass. So I want to go 2 passes, and the question states that for the multi-passes, the spacing is half of the diameter of the cutter. Now that diameter is 25 mm, so I have 12.5. So 2 passes will do. Green tick and regenerate. We are now able to okay, continuing. You see the next operation on the paper, which is a slot drill of the 8 mm hole, this hole. Okay, go back to isometric to see the hole nicely. This is the hole that we need to drill. So we go to drill and select the center and green tick. So tool. So we have to look for a tool. Okay, so create a new tool. So with this, we are using a spot drill. So what is the size of the spot drill? We look at the drawing here. The hole that we are drilling is this one, which is diameter 8. The spot drill should be bigger than this. Although we are not going to produce any chamfer, but the spot drill should be more than this. So now if you look at the table, okay, spot drill over here, no, here, spot drill, there are two of these, one is 8 mm, one is 12 mm. So as the spot drill need to be bigger than the 8 mm, so I can only choose the 12 mm one. So back to here, now I need to use spot drill 12, and I need to use this tool. Next, this is tool number 9, and material is high speed steel. Calculate the speed and the feet, and this is okay. This is no need to change. Okay, so again we have to coolant on, then finish. Okay, so we'll be using this tool. Cut parameter, nothing to change. Linking parameter, check and check. This 5 mm, and top of the stop is 0. How deep are we going down into? So because the hole itself is 8 mm hole, and we don't want to have any chamfer, so the depth I want to go down is -4 mm only. Okay, so with that, green tick. So there we are. We have spot drill. Okay, so next operation is the peg drill. So peg drill, drill. Again, I want this hole. Green tick. Tool. So create new tool. I need to twist drill, and the diameter is 8. We need to drill an 8 mm hole. So next, tool number is for this twist drill is 11, number 11, and material is also high speed steel. So with this we calculate and coolant on. Then I will come to here. I will change this to peg drill. With the peg, first peg is 50%. Okay, so with that we say finish. Okay, so cut parameter is peg is 4 mm, linking parameter 55. This is 0. How deep are we going down into? Okay, so if you look at the work piece, if you look at the drawing, is below here. Okay, this is the hole that we are drilling. 4 plus 7, 4 mm here, 7 mm here, so altogether is 11 mm. So we are going down by -11. However, we never calculate this conical part, so we have to calculate the conical part by making use of this formula. This is a calculator icon here. Click on it. 8 mm initially, final is also 8 mm. So now the computer calculated that to the conical part we have to drill in extra -2.4 mm. So add this to the value here. So green tick. So this is total depth that we have to cut into. So with that, green tick. So this is the hole. Okay, after we finish the hole, we finished the hole already. Now we want to do this pocket, this area here. Before that, we will have to use wireframe, create a pond. So select this circle. So that create a pond. We need to, when we do pocketing, we need to use drill hole. So we have to tell Mastercam that you have to go down. The MU has to go down around this hole. So we'll now go to toolpath and followed by pocket. And first of all, we will say pond, and we will select this pond. Okay, should be okay. Select the point. Okay, let's start again. I forgot. All right, let's go pocket. We'll select the point. Select this point. After that, the solid. Now loop. I want to go for this loop. Okay, but at the same time, because we want to avoid this island, we have to select the island as well. Then okay, so with all this, okay, now this is in this area, excluding this area is the area that we want to cut. So okay, green tick. The next thing is we have to look into the tool that we need to use. So now we have to go into the drawing. This width is 45. The diameter of this is 23. So let's go to the calculator. 45 minus 23. So our value is 22. So 22 meaning that 11 mm here, 11 mm over here. So we have to look for a tool that is just nice, that good enough to go through this gap. So we'll take a look at the paper. So which tool? So okay, we are looking at possibly tool number 6 and 7 for roughing and finishing. 8 mm. There's an 11 mm gap. However, we also want to give some allowance, so we are using 8 mm tool. So with this, we'll right click, create new tool, and flat and mill. So we say 8 mm, and next, this tool, 8 mm tool, is tool number 6. So we type in 6, and it is 2 foot. Material is 2 foot. Material is high speed steel. So we calculate, and okay, so this is an end mill. Okay, and calculate. Okay, we'll do finish. Okay, so tool number 6, we are using this tool. Cut parameters. Where this pocket we want to leave 0.2 mm behind on the wall, but nothing on the floor. We will do finishing. Roughly, roughing is constant overlap spiral, 50% overlap. Entry motion we are using off because we want to drill hole. Finishing, nothing to be required at the moment. Then depth of cut. Depth of cut is, if you look at the paper, it says that the depth of cut is 20% of the tool diameter. So 20%, 0.2 times the cutter diameter, which is 8. So we have 1.6. Keep tool down, and linking parameter 50 on top, uncheck retract. Flipping is 5, and top of the stock is 0. I go down to -4. The pocket is 4 mm. Okay, so this is the pocketing. Okay, so we'll now continue with the finishing pocket. So this is rough pocket. Right click, I copy and paste, copy and paste. So this is, of course, we have to change the parameters. Now again, first of all, tool. Number 6 is a roughing tool, so I have to create a new tool. Number 7, which is a finishing tool. It is still 8 mm in diameter, but tool number 7, 4 flutes, high speed steel, calculate, and okay, that will do. So done. So cut parameters. Now we are not leaving anything behind because this is a finishing operation. We are not doing any roughing already. Finishing now. Finishing, I will use take in the default values, and then I will do all this in one pass. So lead unit out. Uh, we are using perpendicular and 1 mm. Then depth of cut, one pass will finish all. Pocket finishing, one pass. So linking parameter same. So let me check again. Lead unit out. Finishing. We are using computer because the question says that we are using computer all the time. So roughing uncheck. Cut parameter 0. Okay, so this is our final thing. So green tick and regenerate. No, did I change this? Did I do regenerate? Reinitialize? Yeah, I didn't. Okay, so again, now I have to regenerate again. Okay. Okay, let's continue with the next operation, which is the finish milling of the contour. So this is the contour second operation. I copy and paste, copy and paste below. So now I will modify the parameters. First of all, the tool. We need the earlier on we are using tool number 2. That was a roughing tool. So we want to use a finishing tool. So possibly that we can make use of. Well, we want a bigger diameter one. So we are thinking of using tool number 3, which is a finishing tool, but 16 mm in diameter. And tool number 3, yes, correct. It is high speed steel. And number first is 4. So calculate. Okay, so finish. Now I have to initialize the speed and fit. Cut parameter, we are still using computer, but this is finishing, so no material to be left behind. One cut will finish all, so we will not be using any depth of cut. Lead unit out 100% and 1 mm of overlap. We don't need multi-pass this time now because we are doing finishing. 50, okay, all this alright, correct. So we'll just green tick. Regenerate. Okay, so next we will try to drill the 4 holes. 1, 2, 3, 4. Okay, I think maybe I also want to do this. Now the two paths are too messy, so I want to hide away all the two paths, so easier for my next operation. Okay, so now my next operation is drill. I want to drill these 4 holes, so I select hole number 1, number 2, number 3, number 4. So 4 holes, 2. Now again we have to check the tape paper on the drawing. What do we have? Okay, this 4 hole, we have to create a countersink, which is diameter 11. So meaning that my spot drill must be bigger than the diameter 11. So for that, I will go to use this one, which is diameter 12 spot drill. Okay. So we are cutting a countersink of 11 mm. So this is good enough. So cut parameter, nothing to change. Linking parameter 55. Top of the stock is 0. How deep are we going down into? Because we want to cut down by 11 mm, so minus 5.5. So with that, green tick. Okay, the next operation is the last for the first operation, for the first side. We'll drill 4 holes. Okay, or maybe I will copy and paste. No, I will copy and paste. Right click, copy and paste below. The same 4 holes, so I don't have to reselect the holes again, but I have to change the tool. The hole itself is diameter 10, so I have to create a drill which is diameter 10. Drill diameter 10. Then next, this tool number is 12, and material is high speed steel. So calculate. Okay, so this is diameter 10, number 12, high speed steel. Then and now this is back drill, so we change to back drill, and first back being 50%. So with that, finish. So this is tool number 10, tool number 12. We initialize the speed and fit, and cut parameter. Okay, correct. Linking parameter, I will have to go down. So again, we'll look at the drawing. We are now cutting this hole from this surface down, by how much? Well, at least it is 15, but of course we want the tool to go through. So with this, I will say top of the stock incremental 0 from the surface that we pick. Okay, we just now we pick this surface here, so from the surface that we pick, 0. I go down by how much? Minimum 15. Minimum 15. However, that just means that the conical part of the drill will reach to 15. So that is not enough. This time round, I don't have to use this calculator, because now as long as I make it through, I will be happy. So this calculation, even if you calculate, is about 3 point something. So we make it minus 20. Okay, so that will make it make sure that we have allowance, as well as the conical part of the drill get through the workpiece. So with that, green tick. Regenerate. So we finish the first side. Okay, so save this as, okay, I will save it under revision 2012. Okay, and I also see that my NC file name is p.nc, so rather I want to change this to emission number. So select all, right click, add the selected operations, change your NC file name to your emission number. Okay, program number is 2001, that is correct. So with that, we save the file and we will continue in the next video.